Times has them, and today we're going to look at the Lockheed Martin F-35 Lightning II and the tech that's in it, and can it be hacked, and should you buy it. Now, absolutely don't buy it, because you don't have $170 million and you're not a government. But if you are a government, you should pay attention. If you're not a government, you should also pay attention, because there's some crazy tech in here, and it's messed up from what I can tell. So, this plane has been under development by Lockheed Martin for the last 15 years, and now the United States is finally selling it to various countries, and there's been speculation that they can shut it off remotely because of the software updates. And people said, no, that's impossible, can't do that, so I decided to get to the bottom of this. So right now the plane is in service in a whole bunch of countries, and I can't remember, Korea, United Kingdom, Australia, a bunch of European countries with flags that are quite similar, and then a whole bunch more countries are buying it, including Greece, Canada, Japan, which was a dot somewhere, I can't remember, and then or maybe it was on the other side, and then Turkey, and a bunch of other European countries with similar flags, but I digress. So it's got a whole bunch of different weapons you can put on it, like missiles, other smart bombs, and these things can be radar guided or laser guided, and that's very cool because you can add whatever weapon system you want to it, and then it can deploy that weapon and guide it, and that's great. But okay, what we didn't know was it's got the coolest thing ever now, which is a so even though the plane's made by Lockheed Martin, it's got a phased active electronically scanned array. So this is basically a radar system, and it's not made by Lockheed, it's made by Northrop Grumman, and it's integrated into the plane, and it kind of looks like a honeycomb. But what's cool about this thing is it's got a whole bunch of like circuitry. So we call this a software defined radio, and by that I mean if you think of a radio antenna, the radio antenna operates at a certain frequency, and the frequency that it operates on depends on the shape of the antenna. But now they've invented what we call a software defined radio. So this antenna can operate in different directions and at different frequencies without having any actual moving parts. And the reason this is important is because the enemy will try to come in, and if they want to disable your plane in a war, they'll send out a really powerful radio signal to jam your radio signal. And so a device that's picking up a radio signal, let's say I've got one plane that's communicating with a base station, so the plane is going to pick up the signal that is the strongest and think that's the signal that it wants to talk to. So if somebody comes in with a really close by to your plane and sends out a whole bunch of gibberish, noisy radio signals, that will jam the sensor on your plane, and then your plane won't be able to hear the signal coming from the ground or from a satellite because it's jammed. It's like if you're in a room and you're trying to listen to somebody really far away, and some guy comes and starts yelling random words into your ear, you're not going to be able to hear what the guy who's far away is saying. And so that's really cool. And because what they can do is they can, instead of sending out or receiving a signal in all directions, they can focus the antenna at a very specific point, and that means that a noisy signal coming from another direction won't interfere with the legitimate signal. Now, I also have this thing called MADL, which is a multi-function advanced data link, and that allows multiple planes to talk to each other in the air, and that uses the antenna we just saw. So this antenna can send signals to different planes in the air, and it can literally point the signal at 3 or 4 or 5 different planes at the same time and laser focus that signal, and it can do it without moving any parts. So it can shift the circuitry inside, and this is a very complicated concept that I'm not going to get into in these in this video, but it's something that we started to see in Wi-Fi access points. We called it beamforming. So that's where the technology originally came from, and it came out, I think, in Wi-Fi version 5, and now it's coming into the military use. Or maybe it came out as military use first, and then people in the private sector figured out how we could use it. But a lot of times cool ideas come from the military, and then they make their way into the commercial space. So having said that, now this radio is made by this radio system is made by Harris, though. So it's another company that made a piece of the plane. Now the thing is, you could have a NATO plane, you could have a Korean plane, you could have a ship, and they can all talk to each other as well. And they use a much weaker signal on the 960 megahertz band, and we call that link 16, which is now originally the signal operated only on line of sight, which means the two planes had to be able to see each other to talk, or so a plane flying on top of a ship, they could exchange signals. But now, for all intents and purposes, communication can take place over TCP/IP, so it can take place over the internet technically, which is also crazy. But now I digress. So we actually have a whole bunch of other devices on this plane. So we've got engines that are made by General Electric and Pratt & Whitney. We've got Harris antennas. We've got the Viavi signal. We've got BA Systems. We've got Collins Aerospace, which has computers and screens in the cockpit. And all this stuff, including the helmet, it all has to talk to each other, and it talks to each other over a fiber channel switch. This is the fiber channel switch. So this is the same extremely high speed communication device that we see in data centers, although this is a military version of it that looks way different, but the tech is the same. So big companies will use fiber channel to transfer a ton of data on their server space and storage appliances. And interface for the antennas looks like this. But having said that, here's where it gets really weird, because when you think about it, each of these is made by a different company, and then every component is made up of a whole bunch of little subcomponents that are made from their subcontractors. So there's little bits of circuitry in each one. And we add motors, and now we find out that a lot of the circuitry is actually made in China by Chinese companies, which is not cool, because when you look at a circuit board like this one, this is what we call an integrated circuit. So it's a computer chip, and it could be anything in any device, but in this case we've got a computer circuit board right here, and if we look here, we've got a whole bunch of wires that are soldered on, and these are like, they take data and they make decisions. So electrical signals flow along these pathways, and then they get to a point. But we also see these black things, which are little microchips, and each of these has a little tiny piece of software, and each of these does process data in a certain way. And it does that. So each of these little like teeth is a wire that's receiving a signal or sending a signal. So we get signals coming in, and then this thing has software. It's making a decision, and then it's deciding what to do, and then it's sending the signal back out somewhere, and then it might go to another processor. So this thing could have like this would have a very specific function, like processing a radar signal, for example. But really, when you have, so you in a plane, you could have like 10,000 of these little things. If you count this, because maybe you get 3 or 4 or 5 of these in a component, and then you've got hundreds of components across the plane. So you've got like now hundreds of manufacturers' pieces went into the plane, and each one has code. And so this might be 3 layers of subcontractors before it gets to this chip, right? Because you can see on this board, we've got chips from 3 different manufacturers, just like that. And so, I'm going to show you an example. If you think of the iPhone has a camera chip, and then it's got a gyroscope chip, and it's got an encryption chip, and it's got a modem to communicate with the cellular network, and then with the Wi-Fi. So, and this chip, the modem, cellular modem, is made by Qualcomm. That's inside your phone. But Apple has a really tightly controlled software. So what happens is the phone has a digital signature that Apple made that's literally burned into the phone, and you can't change it. And so when you go to download iOS or download an upgrade to your iOS, the phone checks the signature on the file before it comes off your computer and decides whether it's legitimate or not. So nobody could make a fake version of iOS and try to load it onto your phone. It's not possible. I mean, there's always hacks and stuff, but generally speaking, it's not possible. And a lot of this is also enforced by the Apple encryption chip. So there's what's called this is called a hardware root of trust, because the chip in the phone literally has the signature burned into it. So it's not, so nobody can change the signature that's on the phone, and if it doesn't match, then you're not gonna get that software onto the phone. And that's also a topic for a long video by itself. But now think about something. So a couple of years ago, 3-4 years ago, we had a company called SolarWinds, and SolarWinds has network management software that a lot of people use, a lot of big companies use, including the government. And when you go to download SolarWinds, SolarWinds digitally signs their software before they send it to you. So when your Windows computer downloads SolarWinds, it checks the signature and makes sure that it's a legitimate file, which is okay. But what happened is some hackers got into SolarWinds, and they got into the SolarWinds developers' computers, and they put viruses into the software before it got released. And so SolarWinds signed the software with the viruses in it, not knowing that there were viruses in it. And then those, since they're legitimately signed by SolarWinds, those all ended up on government computers, thousands and thousands of them, and then those computers got hacked. So that could happen with this plane too, and here's why. So now let's pause here, and we'll make a second video, part 2.